Okay, hello everyone. Today let's talk about uh past paper, paper 4. We start from number 1. Let's read the questions first. Calcium chloride CaCl2 is an ionic solid, and given energy change of lattice energy, standard enthalpy change, atomization of calcium, first ionization energy, second ionization energy, and so on. So questions number 1A, define what is the definition of lattice energy. So when you are asked these kinds of questions, so you can start by the definition is energy. We talk about energy change when we talk about a lattice, means that we are going to form an ionic compound or an ionic solid. So when 1 mole of ionic compound or solid is formed from its element or from its gases ions. So the keyword right here is energy change. 1 mole ionic compounds form from its gaseous ions. So the ions should be in gaseous state. All right, part B, use the data in table 1.1 to calculate the standard enthalpy change formation of calcium chloride. So in here, we need to determine the delta HF of calcium chloride. What is calcium chloride? CaCl2. It may be helpful when you draw the energy cycle. Okay, since we know that our product here is CaCl2 solid, so I started from the product. CaCl2 solid. How to form this product? Or we call it as delta H formation. To form CaCl2, you can form it from its element in the standard condition. So we have calcium. Usually calcium is in the state of solid plus Cl2. Cl2 is in a gas form. Yeah, we call this one as delta HF. And then we want to obtain Ca2 positive gases and Cl negative gases. So we start from calcium first. Let's convert calcium solid into calcium gas. Just copy paste Cl2. Okay, from calcium solid to calcium gas. So we call this one as delta H atomization of calcium. Right, now, since we have formed calcium gases right here, then we can convert calcium gases into its ion. It lose 1 electron, become calcium positive gases plus Cl2 gases lose 1 electron. So we call this one as delta H ionization, the first ionization energy. Next, and we lose 1 more electrons from Ca positive, become Ca2 positive plus Cl2 gases plus 2 electrons right here. So we call this one as delta H ionization second stage, or the second delta H ionization energy. Then here we already obtained Ca2 positive gases, the one that we want. Next, we need to convert Cl two gases into its atom, into Cl gas. All right. So right here, we copy paste Ca2 positive gases plus 2Cl gases. Okay, we call this one as delta H atomization of Cl. Okay, next from here, we can make as the ions, right? We convert Ca2 positive become 2Cl negative. Ca2 positive plus 2Cl negative gases. This is gases. We call this one as delta H Ea. All right, and then until here, since we have obtained two ions of gases, Ca2 positive to Ca2 positive plus 2Cl negative, and then we can obtain the ionic compound CaCl2. We call this one as delta H lattice. All right, and then I want to give you some note here because in here there are two atoms, so you need to multiply it by 2. Anyway, okay, then you can substitute the number. Okay, delta HF, this is the one that we need to calculate. Delta H lattice, we have minus 2 to 37. And then delta H, wait a minute, delta H atomization of calcium, delta H atomization of calcium is positive 193. And then we have delta H1 ionization. The first ionization energy of calcium is positive 590. And then the second ionization energy we have positive 1150. Then delta H atomization of Cl. Delta H atomization of Cl is positive 121. Right here, we have 2, right? And then 2 coefficients, so you multiply it by 2. Right, next, we have delta HEA of Cl. Delta HEA of Cl, okay, minus 364 times 2. Minus 364 times 2. Then, I think that's it. And you sum it all. Then the final answer later on become delta HF equal to negative 790 kilojoule per mole. Okay, so this Born-Haber cycle will help you to check each stages, so you will not miss anything. Okay, part C. 3 possible values for the first ionization. Sorry, 3 possible values for the first electron affinity of bromine are shown in table 1.2. One of them is correct. Please tick by the correct value. Explain your choice. All right, so we have known that EA of Cl is minus 364. Oh, Okay, so you need to predict EA of Br if given EA of Cl is about negative 364. As we know that in the periodic table of halogens groups, there is FCl, Br, and I. And down the group, the atomic radii is increased. So it means that atomic radii of Br is bigger than Cl. So Ea of Br has less energy than Cl. So you can find out which one has less energy than negative 364. So the answer is negative 342. So this sign means that release energy or exothermic. Well, we move on to part 1b. The enthalpy change of hydration of the chloride ion can be calculated using the lattice energy of calcium chloride and the data shown in table 1.3. There is a data of standard enthalpy change of CaCl2 negative 83 and enthalpy change of hydration of Ca2 positive negative 1650. Define what is enthalpy change of solution. Yeah, enthalpy change of solution is talking about energy that is absorbed or released when 1 mole of ionic solid dissolves in sufficient water to form very dilute solution. So this is the hint, ionic solid, 1 mole absorbed and released, where enthalpy change of hydration is energy change when 1 mole of specified gases ions dissolves. So in here, the one that we dissolve is gaseous ion in sufficient water to form very dilute solution. Okay, next. Calculate the standard enthalpy change of hydration of fluoride ion Cl negative gas. It may be helpful to draw an energy cycle. Show all your working. Okay, so in here we have ionic solid, right? Ionic solid of calcium chloride. So we start from CaCl2 solid. Well, CaCl2 solid is formed from calcium 2 positive gases plus 2Cl negative gases. We call this one as delta H lattice. Then these gases, when we dissolve it in a solution, it will form calcium 2 positive aqueous plus 2Cl negative aqueous, we call this one as delta H hydration. Then calcium chloride solid, when you dissolve it in water, will form calcium 2 positive aqueous and 2Cl negative aqueous. We call it as delta H solution. So you can see the difference. When we talk about delta H hydration, means that we dissolve the ions gas in a solvent, where when we talk about delta H solution means that we dissolve the ionic compound solid. Nah, then what is the delta H hydration? You can get the data delta H lattice from this table before. We get the data is about negative 2237. Negative 2237 minus, okay, then delta H solution, we have negative 83, and then hydration, we have negative 1650, divided by 2, because there are two coefficients there, then the answer is 335 kilojoule per mole. It's negative, or we call it as exothermic reaction. Okay, next we move on. Okay, this topic is about entropy. Yeah, calcium chloride CaF solid can be synthesized directly from its element. There is a value of delta HF of CaF2 negative 1214 kilojoule per mole. The sign of entropy change is, now from here we know that calcium 2 positive gases plus 2F negative gases, it will form CaF2 solid. Am I right? So since the number of particle gases from reactant and product is lesser, so we can say that the enthalpy change so the sign of entropy change is negative. Yeah, because reduce the number of particle gas. Lesser or least entropy. Okay, use the value of delta HFCF to given an answer to predict how the feasibility for the synthesis will change with increasing the temperature. You have to know that there is a formula of delta G equal to delta HR negative T delta S system. When you increase the temperature, of course, the delta G become more positive. When it become more positive, then the T delta S will be more negative. Or we can say it like less spontaneous or less visible. Okay, next. For number 2, this topic is about rate of reaction. There is a given reaction here. Okay, this reaction is first order with respect to both NO and O3 at this temperature, and this is the rate constant. Complete the rate equation for this reaction. So the rate of reaction R equal to K times concentration of reactant. The reactant is NO. Because this is the first order reaction respected to NO, so this is 1 times concentration of ozone respected to 1. A reaction is carried out in which the initial concentration of NO and O3 are both the same concentration. So what is the rate of reaction? Then you can substitute this equation to calculate that. R equal to K. K is, I think it's given here, 1,500 mole negative 1 dm cube as negative 1. You have to copy paste the unit so you can find out the final unit later on. And then concentration of NO is this one, 1.20 times 10 to the power negative 6 mole per dm cube. Since the concentration is same, then we can make it square. So later on, if you do the calculation, the rate of reaction is 1.66 times 10 to the negative 8. The unit is mole, because this is mole square, negative 1 mole, so mole only, dm negative 3 as negative 1. The reaction described in AII is monitored over a period of time. Predict whether or not the graph of NO against time under this condition shows that the reaction has a constant half-life. Explain your answer. Prediction, it will be not constant, because the overall reaction is second order. Okay, nitrous oxide and 2O decompose into its elements. Sketch a graph of the axis below of the reaction rate against time for the catalyst decomposition of N2O under this condition. So in here, x-axis is time and y-axis is reaction rate. So because this is second order reaction, then the graph will be a linear like this to y-axis. Sketch a graph on the axis below, concentration of N2O as the y-axis and x-axis as time. Again, because this is second order reaction, then there will be a constant line here. Platinum behaves as a heterogeneous catalyst in this reaction. We know that platinum is solid. Describe mode of reaction as heterogeneous. What is heterogeneous catalyst? So I will give you the hint for this. When we said the heterogeneous catalyst is the state of matter for the catalyst and reactant are different, and there will be an adsorption of reactant to atoms on the surface of solid, and the bonds in reactants will be weakened. Reaction occurs followed by desorption of products. All right. Suggest a reason why this reaction has zero order kinetics when the amount of nitrous oxide is large and the amount of platinum is small. That's because all the active site of catalyst surface are occupied. Okay, next. Data should be selected in table 3.1 in order to answer this part of questions. So this is about electrochemistry, especially about electrode potential cell. So this data is given. Let's read the questions. A part I. Define standard electrode potential. Include the details of standard condition. When you are asked about the electrode potential, you can start from, the unit is voltage, right? So you can say that it's talking about the voltage produced by a half cell. If you see here, this one all are half cell compared, and we compared this half cell with a standard hydrogen electrode. Okay, the standard condition is 1 mole per dm cube, and then temperature is in 298 Kelvin, and the pressure is 1 atmosphere. Complete the diagram below to show electrochemical cell constructed from Mg2 positive to Mg. This is the first half cell, and the second half cell is MnO4 negative to Mn2 positive. So we can highlight this one and this one. From this data, we can see that because the MnO4 negative is more positive than Mg2 positive, so we can say this one as reduction. Then this is oxidation, right? That's the first thing. The second thing, we have to know that in reduction always happen in cathode. In cathode, there will be reduction. In anode, there will be oxidation reaction happen. And then, cathode is a positive electrode, and anode is negative electrode. That's it. Okay, then we can draw this one. First, we need to draw a wire with an electrode. Since we have two kinds of electrode, that is Mg and Mn. Electrode always a metal, and we connect it to the voltage. Then, which one is the negative electrode? The negative electrode is anode for oxidation. This is negative, this is positive. So Mg is negative electrode. So this is negative and this is positive. Okay, next, in here we have ions. The ions in Mg is Mg2 positive, where in Mn there are two ions, MnO4 negative and Mn2 positive. So we can add it here. There is Mg2 positive right here. There is MnO4 negative and Mn2 positive ions there. Then don't forget to connect this one by salt bridge. Okay, we call this is salt bridge. Usually the salt bridge is used as KMnO3. Okay. Don't forget also to mention this, the condition. It should be in 1 mole per dm cube, 1 atmosphere, and 298 Kelvin for the temperature. Use a positive and negative sign to identify polarity of each two electrodes. This is negative and positive. Use an arrow and the symbol of electron to show the direction of the electron flow. The electron flow from negative to positive. So I will draw the electron flow is right here. Calculate the standard cell potential E cell. Okay, this is very easy for you guys. You have to know this formula. E standard cell equal to E standard cell for reduction minus E standard cell for oxidation. You have known here reduction is positive 152. Voltage negative oxidation, we have negative 2.38. Am I right? Yes, correct. So the final answer will be 3.90 voltage positive. All right. Construct an equation for the cell reaction. We can continue this one in next meeting. Thank you so much.